What is global warming? The global is heating up. Both land and oceans are warmer now than they were when record keeping began in 1880, and the temperatures are still ticking upward. This rise in heat is global warming in a nutshell. Here are the bare numbers. According to the National Oceanic and Atmospheric Administration (NOAA), between 1880 and 1980, the global annual temperature increased at a rate of 0.13 degrees Fahrenheit, 0.07 degrees Celsius per decade on average. Since 1981, the rate of increase has sped up to 0.32 degrees F, 0.18 degrees C per decade. This has led to an overall 3.6 degrees F, 2 degrees C increase in global average temperature today compared to the pre-industrial era. This rise in heat is caused by humans. The burning of fossil fuels has released greenhouse gases into the atmosphere, which trap warmth from the sun and drive up surface and air temperatures. How the greenhouse effect plays a role. The main reason of today's warming is the combustion of fossil fuels. These hydrocarbons heat up the planet via the greenhouse effect, which is caused by the interaction between the Earth's atmosphere and the incoming radiation from the sun. Simply put, solar radiation hits Earth's surface and then bounces back toward the atmosphere as heat. In a paper presented in 1895, they figured out that greenhouse gases, such as carbon dioxide, could trap heat close to the Earth's surface, and that small changes in the amount of those gases could make a big difference in how much heat was trapped. Where the greenhouse gases come from? Since the beginning of the Industrial Revolution, humans have been rapidly changing the balance of gases in the atmosphere. Burning fossil fuels like coal and oil release water vapor, carbon dioxide, CO2, methane, CH4, ozone, and nitrous oxide, N2O, the primary greenhouse gases. 1. Carbon dioxide. Carbon dioxide is the most common greenhouse gas. Between about 800 years ago and the beginning of the Industrial Revolution, CO2's presence in the atmosphere amounted to be about 280 parts per million, ppm, meaning there were about 280 molecules of CO2 in the air per every million air molecules. As of 2018, the average CO2 in the atmosphere was 407.4 ppm. In 2016, CO2 accounted for 81.6% of all U.S. greenhouse gas emission, according to an analysis from the Environmental Protection Agency (EPA). CO2 makes its way into the atmosphere through a variety of routes. Burning fossil fuels releases CO2 and is, by far, the biggest U.S. contribution to emissions that warm the globe. According to the 2018 EPA report, U.S. fossil fuel combustion released just over 5.8 billion tons of CO2 into the atmosphere in 2016. Other processes, such as non-energy use of fuels, iron and steel production, cement production, and waste incineration, boost the total annual CO2 release in the U.S. to 7 billion tons, 6.5 billion metric tons. Deforestation is also the large contributor to excess CO2 in the atmosphere. In fact, deforestation is the second largest anthropogenic human-made source of carbon dioxide, according to research published by Duke University. After trees die, they release the carbon they have stored during photosynthesis. Deforestation releases nearly 1 billion tons of carbon into the atmosphere per year. 2. Methane. Globally, methane is the second most common greenhouse gas, but is the most efficient at trapping heat. Methane is 25 times more efficient at trapping heat than carbon dioxide. Methane can come from many natural sources, but humans got a large portion of methane emissions through mining, the use of natural gas, the mass raising of livestock, and the use of landfills. Effects of global warming. Global warming doesn't just mean warming, which is why climate change has become the favorite term among the researchers and policymakers. Climate change can and will affect the globe in several big ways: by melting ice, by drying out already arid areas, by causing weather extremes, and by disrupting the delicate balance of the oceans. Melting ice. Perhaps the most visible effect of climate change so far is the melting of glaciers and sea ice. A 2016 study found that there is a 90% chance of global warming has caused the recent retreat of glaciers. In fact, the research showed these rivers of ice retreated 10 to 15 times the distance they could have if the climate had stayed stable. Glacier National Park in Montana had 150 glaciers in the late 1800s. Today it has 26. The loss of glaciers can cause the loss of human life. For example, the avalanches caused burying villages. At the North Pole, fall and winter ice hit record lows in both 2015 and 2016, meaning the ice expanse did not cover as much of the open sea as the previously observed. Some scientists think the Arctic Ocean will see ice-free summers within 20 or 30 years. Heating up. Global warming will change things between the poles too. Many already dry areas are expected to get even drier as the world warms. A study predicted an 85% chance of droughts lasting at least 35 years in the region by 2100. The main reason the researchers found is the increasing evaporation of water from hotter and hotter soil. Much of the precipitation that does fall in these arid regions will be lost. Meanwhile, 2014 research found that many areas will likely see less rainfall as the climate warms. Extreme weather. Another impact of global warming. Extreme weather. Hurricanes and typhoons are expected to become more intense as the planet warms. Hotter oceans evaporate more moisture, which is an engine that drives these storms. Paradoxically, climate change may also cause more frequent extreme snowstorms. According to the National Centers for Environmental Information, extreme snowstorms in the eastern United States have become twice as common as they were in the early 1900s. Ocean disruption. Some of the most immediate impacts of global warming are beneath the waves. Oceans act like carbon sinks, which means they absorb dissolved carbon dioxide. That's not a bad thing for the atmosphere, but it isn't great for the marine ecosystem. When carbon dioxide reacts with seawater, the pH of the water declines. That is, it becomes more acidic, a process known as ocean acidification. This increased acidity is a way of the calcium carbonate cells and skeletons that many ocean organisms depend on for survival. These creatures include shellfish, pteropods, and corals. We really need to be serious about this. If not, it is we who are melting in this increasing hot sphere.